Yes, welcome dear students. We are going to start alternating currents. As we know that alternating currents is the current which is change in magnitude and directions. That's why we call this is alternating. When you apply this current in in a circuit with different elements, we are going to find the relations between voltage and current. Let us start the first topics when there is a resistance in the circuit. So how the current and voltage are related in terms of the phase. Let us suppose our source voltage is E is equal to E naught sine omega t. This is alternating current and it is sine omega t sinusoidal function. We know that in the sinusoidal functions it is varying in current and with directions also. We know that it has different magnitude, like this is height of this known as the magnitude, and it is the positive directions and it is the negative directions. So in a time intervals t, it is travel a distance of 1 oscillations, and we have omega angular frequency. This is our angular frequency. Different countries have different angular frequency. In India we have AC has the frequency 50 Hz. In India, this is according to the usage of hours, and USA it has a frequency 60 Hz. By the Kirchhoff's law, we know that the total voltage across the circuit elements is equal to 0. The voltage with vary with time is equal to 0. That's why E is equal to IR. I the current in the circuit when there is a resistance. If I put the value of E naught sine omega t is equal to I into R, from here we will get the value of I, which is E naught divided by R sine omega t. As we know that sine omega t has a maximum value, sine omega t has a maximum value plus minus 1. If I put the value here, we get the value maximum current or amplitude of the alternating current, which comes out E naught divided by R. If I put these values in relation, E I is equal to I naught sine omega t. So now if we compare the phase angles of the AC voltage, which is omega t, and here the sine omega t, both are the same, we can say that current and voltage are in the same phase. Therefore current I and voltage are in same phase when there is only one circuit element, that is the resistance. We are not showing the direction of current in this circuit because the current has always changed its directions. So in a 1 second it changed directions 100 times, because in India we have the frequency of the alternating current is 50 Hz. In 50 Hz it can change directions plus to minus 100 times. So because our eye not accommodating that speed, that speed we can imagine in your brain. Our brain only stored new information only when the things happens within the time duration of 1 upon 10 seconds. If anything happens after 1 by 10 seconds, the image will be framed, the image will be stored in our brain. But in that case, if in 1 second the cycles in the current is changed directions in 100 times, we cannot store the informations in our brain. That's why we cannot show the direction of the current in our alternating current in this circuit. If I draw the graph between voltage and current, we already know that voltage and current are in same phases. So it means that whenever the voltage is maximum, current is also maximum. Whenever the voltage is minimum, current is also minimum. Whenever the voltage is zero at this point, current would also be zero. So because voltage and current are same phases, the phase angles between them is omega t. Omega t is the phase angles. Their phase angles will be here. Omega t. Phase angles normally indicates the positions, the relations between two things in terms of the position and direction. Our next topic is phasor diagram. We can represent the relation between voltage and current with the help of the phasor diagram. In phasor diagrams we represent voltage and current as a phasor vectors. Phasor vectors are nothing, they are just rotating vectors about the origin. We already know that EMF or voltage across an AC is equal to E naught sin omega t. Suppose it's rotating with an angle of omega. At the time of t rotated an angle omega t, well, we already know that omega is equal to theta by t, and theta becomes omega into t. So the projections also in the y-axis of these vectors, this is the voltage vector and this is the current vectors. The projection of these vectors on the y-axis represent the instantaneous value of the current and voltage respectively. This is your current I naught sin omega t, and the projection of these vectors in the y-axis will be E naught sin omega t. Since they are same phase, that's why they are rotating in the same time, same angles, which is omega t. So in this way, phasor diagrams always facilitate to find out the relations between voltage and current whenever there are multiple circuit elements like capacitor, inductors, resistance, and combination of them. If we have capacitors, inductors, and resistors, or combination of them, so it is easy. We can, if we use voltage and current as the phasor vectors, because we can easily simplify them to calculate the phase angles of current with respect to the voltage. Therefore, we generally prefer the phasor diagrams for calculating the phase angles of current and voltage. Now, how to calculate the power dissipated across the resistors are, let us suppose the instantaneous power dissipated across the R is equal to I square R, put the value of I, which is I naught sin omega t square of this multiplied R becomes I naught square, take an R here, sin square omega t. Now we need a time averaged or average power dissipated in the circuit containing only resistor R. Let us suppose the average power dissipated, we can represent this average powers either be P bar taken the average only those elements which contains only time. So average powers becomes in this way. Taken I square not outside of this one. So our average power therefore I naught square or sin square omega t. We know from the trigonometry the sin square omega t has the average power 1 by 2. So we can say the average power becomes, if I write this in this format, I naught upon root 2 becomes RMS value. RMS value, square of the RMS value into R, or it also called effective. IRMS means square root of mean of square of current. The maximum voltage amplitude, which is E naught, is equal to I naught into R. If you divide by root 2, E naught upon root 2, we already know that I naught upon root 2 is IRMS. We can say in this way, E naught upon root 2 will be ERMS, root mean square voltage. In the previous part, I have written the average power of sin square t. Sin square omega t is 1 by 2. How it becomes 1 by 2? Let us suppose we know that sin square omega t, we can write from here cos 2 omega t is equal to 1 minus 2 sin square omega t. So from here, if I calculate the value of sin square omega t, it comes out 1 minus cos 2 omega t divided by 2. So we know that if I draw the graph of cos omega t, it comes out like this. So it has equal half cycle is positive and half cycle is negative. Half cycle is positive, half cycle is negative. The average powers becomes in this case cos 2 omega t equal to 0. If I find the average value of in this way, sin square omega t is equal to average of, if I split this one 1 by 2 minus cos 2 omega t divided by 2. We already know that the average of cos 2 omega t is 0. Therefore, we found that the value comes out 1 by 2. In this way, I have placed sin square omega t is equal to 1 by 2 in the previous part.